so now we're moving on to combinations. And we use combinations to count the possibilities when order is not important. We're not concerned necessarily about who comes first, who comes second, who comes third. All right, so let's take a look at an example. Your pet cat had a litter of 3 kittens that you're now looking for new homes for. One person wants to adopt 2 of the kittens. So how many different possible pairs of kittens could he choose? All right, let's say you never got around to naming these kittens, so being the good math students you are, you called them X, Y, and Z, because you like variables. Okay, so let's think of all the pairs of kittens we could have. You could take kitten X and kitten Y, kitten X and kitten Z. Or you could take kitten Y and kitten X, kitten Y and kitten Z. Or kitten Z, kitten X, kitten Z, and kitten Y. Alright, so those are all the possible combinations if order isn't important. But notice that we have some duplicates. I'm not really worried about the order, but obviously I can't, once the 2 kittens are taken from one set, whether it's XY or YX, alright, that's the same 2 kittens. So let's cross off the duplicates. This is a little bit different from that dice question we had on the exit ticket, where you wanted a 5 whether it was on the first dice or the second dice. It didn't really matter about the order. Here, we're not really concerned about the order. We're just concerned about not counting the duplicate pairs. All right, so ZX, we already have that taken care of, and ZY, we already have that taken care of. So there are 3 possible combinations of the kittens pairing up and going to their new home. Alright, now again, the reason why we go through all this is because we want to save time on having to write out and draw out all these combinations and all these sample spaces. We're trying to mathematically do this instead of writing out all the possibilities. So let's take a look at our example. Okay, so a restaurant offers you a choice of 2 different side dishes from a list of 8. How many different options do you have if you choose 2 different sides? Again, the key word here being on different sides. We're not doubling up on the same order of French fries or whatever your favorite side happens to be. So you're choosing 2 different options. All right, so I could have 8 possibilities for the first one, and then that leaves 7 possibilities for the second one. But because when I list all those, if I were to draw out that tree diagram again, where I'm listing all the possible combinations, I'm going to have the same 2 sides, whether I meant to or not. So let's divide that list in half. So 8 times 7 is 56, but I'm taking 2 at a time, and I don't want any, I'm not worried about the duplicate orders because it's the same 2 sides, whether I got the French fries first and then the mashed potatoes, or I got the mashed potatoes and then the French fries. Apparently, I'm really hungry for potatoes in this example. So again, the order not being important, I'm just looking at, did I get these 2 choices? That gives me 28 options, 28 different possibilities of the side dishes. Okay, now again, as you know, this is new level math, so we're taking it to the next level, and we want to shortcut that, again, without having to really, put too much crazy thought into it. So let's take a look at how we use this with our calculators. It helps if the computer works for us. There we go, finally. So, how do we find combinations? To find the number of int objects taken r at a time, divide the number of permutations of the int objects taken r at a time by r factorial. Okay, so what does that all mean? Well, again, using the n and the r as the example showed us, this is our symbol, NCR, which I'm sure you could have guessed since we've already talked about NPR and factorial, the NCR was the one in the middle. Okay, as the word problem told us, we're taking the number of permutations divided by r factorial. Well, here's the formula for finding the permutations of n objects taken r at a time. So if we write that in, And then dividing by r prime means multiplying by 1 over r, not r prime, r factorial. So then we multiply by 1 over r factorial, we end up with this formula. Now that's if you're going to do it by hand, plugging in all the numbers, crossing off the common factorials, and then going from there. I don't want to do that. Use your calculator, go to your math probability options, whether, again, hopefully by now we figured it out. If not, we'll talk about it in class. Google it. You know, all things can be answered by Google, it seems. There's probably even a YouTube video out there about that. So use your probability function, type in whatever your n value is, hit the keys necessary to get the NCR, and then type in whatever your R value is, hit enter. That's going to give you the answer. And trust me, doing that will save you so much time. Okay, let's take a look at an example of using combinations. This is a little bit real life for you guys since you're in the process of planning what you're going to take for the next year, if not 3 years of your high school career. So you're planning your schedule for school next year. You want to take 3 electives. There are 20 electives from which to choose. So how many different groups of electives can you choose? Again, order is not important here. As long as I've got the same 3 combinations, I don't need to worry about duplicate combinations. So the total objects I have is 20. So n is equal to 20. And I'm taking 3 at a time. I can't take all 20, so I have to choose which 3 to take. Okay, so you're trying to plan your transcript, what's going to look good for those colleges you want to get into. So how many different combinations are there? So write this in the proper notation. And again, writing that down shows me you knew to use combinations instead of permutations. And then using the calculator function to simplify things, 20, whatever the codes are to get to NCR, 3, hit enter, and then you get a final answer of 1,140 different combinations. That's a lot of possibilities to choose from. So choose wisely. Obviously, it takes some time to plan thoroughly. All right, take a look at your exercises. Pause so that you can type these all into your calculator, and then you'll be able to move on. When you're ready, hit play. All right, circle the one you have answers about, and then we'll talk about them in class. Choose between permutations and combinations. Remember that they both tell us the number of possibilities. We use this to count possibilities. But permutations was all about the order. So permutations tell us order, or order is important rather. And then combinations, we don't really care about the order, so if I have duplicates, I don't want to include those. So no worrying about the order. Okay, so for example, there are 40 people who try out for the volleyball team. How many different 12-member teams can be formed? So we're counting the possibilities of these forming. Now, again, does it matter on the order? Now, if I take 12 boys this way and 12 boys that way, it's going to be the same order. You can tell I chose this based upon my own coaching experience. So since order doesn't matter, we would use combinations to find this. Combinations. All right, so, and the way you would set that up is 40C12. Plug that into your calculator to figure it out. I'm not going to do that, the question didn't ask for it. Okay, part B, there are 7 flutists in the school band. In how many different orders can the flutists be ranked? Well, keyword there, orders. So chances are pretty good if you see the word order in your problem, you're going to be looking for permutations. Also, if it describes a scenario in which the order is important, such as ranking, then that's another clue that you need to use permutations. So 7, P, and then we're taking how many? Well, it doesn't say. So how many different orders we would have in one order? So this is actually more of a factorial question. How many different ways can the fluidus be rate? So it's permutation, but we're using the factorial since there's one order that we can look at. Okay, let's take a look at our last example slide, and then we have our last exercise. So finding probability using combinations. So again, probability unit, how do we use it? With combinations. You have a 52 card deck of cards. So this is a fair deck of cards, all the ones you expect to have in there. You randomly draw 4 cards. Find the probability that you draw the ace of hearts, the ace of spades, the ace of diamonds, and the ace of clubs. So we want to know what's the probability that we're going to draw all of the aces. Okay? So, as we calculate this, we know that there's one hand that we're going to get all 4 aces. And this is a combination since the order doesn't matter. I don't care if I draw the ace of diamonds first and then the ace of clubs and then the ace of hearts and then the ace of spades, as long as in the end I have all 4 aces. So this is a combination where I have 52 cards, but I'm only looking for 4 of them. I'm taking 4 cards at a time. So hopefully by now you have practiced enough with your calculator that you know how to use the shortcut key. And when you do that, you end up with a 1 in 270,725 chance of getting those 4 aces. So those are your, that's your probability. Pretty unlikely to happen, but you know, it could happen. It just takes that 1 chance. If not, if you have to do this by hand, make sure you are really good at writing out your factorials and crossing them off correctly. Let's take a look at our last example. Read through it carefully. Determine if you're going to use a permutation or a combination, and then answer the question. When you're ready, press play to get the answer. All right, so there's your answer for you. Have any questions? We will certainly cover this in class. See you Friday.